Hi everyone, welcome to Easy Math. In this video, we are going to see class 7, chapter 2 measurements, in which in the previous video we have seen about parallelogram. Now we'll see about rhombus. Now first of all, what is rhombus? It is a special type of quadrilateral. We all know that quadrilateral is a four-sided closed figure. And we have special types of quadrilaterals as square, rectangle, parallelogram, rhombus, and all these are special types of quadrilaterals in which we are going to see about rhombus. It has four sides. First, let us see the properties of rhombus. What is it? All the four sides are equal, just like square. Even in rhombus, all the four sides are equal. Then what is the difference between rhombus and a square? Even in a square, all the four sides are equal. Then why it is called rhombus then? There is one difference, that is in a square even all the four angles are equal. We know each angle measures 90 degrees. In square, four sides and four angles are also equal. But in rhombus, only four sides are equal, but all the four angles are not equal. Only the opposite angles are equal. These two opposite angles are equal. And these two opposite angles are equal. That is the difference between square and rhombus. And because of this angle property, one more property also comes. In square, the diagonals, when you join the opposite vertices, you get diagonal. Diagonals are equal. But in rhombus, the diagonals are not equal. This measurement is different and this measurement is different. But that is the major difference between square and a rhombus. What is similarity? Means what is same in both? In square and rhombus, in both four sides are equal. But here all the four angles equal, here only opposite angles equal. In square diagonals equal, but in rhombus diagonals are not equal. That is where rhombus is different from square. Okay. And one more property is, another important property of a rhombus is the diagonals. The diagonals bisect at right angles. What do you mean by bisect? They meet at the midpoint. Bisect, meet at the midpoint. So this is one diagonal, this is one diagonal. The meeting point is bisect, means the diagonals are divided into two equal parts. This is equal to this and this is equal to this. For example, if this diagonal is 8 centimeter, then this is 4 and this is 4. If this is 10 centimeter and this is 5 and this is 5. That is the meaning of bisect, divided into two equal parts. At right angles, what is a right angle? Right angle is, we know, 90 degrees. What is right angle? Meeting at 90 degrees. Exactly 90 degrees is called right angle. So the angle between the two diagonals is 90 degrees. This is 90, this is 90, this is 90 and this is also 90. So the third property says diagonals bisect each other at right angles. Okay. Next, these diagonals, see, when you draw two diagonals, the rhombus is divided into 1, 2, 3, 4 triangles. Okay, can you all see that? When you draw, this is one diagonal, this is one diagonal. And how many triangles we are getting? This is one triangle. And we know this is a right angle. So it is a right angled triangle. In a triangle, if one angle is 90 degrees, then the triangle is called right angle triangle. So this is one right angle triangle. Here one right angle triangle. Here one, this is right angle. So it is a right angled triangle. And here we have a right angle. So this is a right angled triangle. So how many right angled triangles are there? 1, 2, 3, 4. So the two diagonals divide the rhombus into 4 equal right triangles. See, I'll read it again. Diagonals divide the rhombus into 4 equal right triangles. It is divided into 4. All the 4 right triangles are equal in size. Okay. And then next property is even the opposite sides are parallel. Opposite sides are, these two sides are just like parallelogram. These two sides are parallel and these two sides are parallel. And well, let us recall, what are parallel lines? The lines which never meet each other. The distance between them remains the same. An example for parallel lines, train track and the ladder. The ladder we climb. to reach the heights. The ladder and the train track are the good examples for parallel lines. They never meet each other. Okay, so here opposite these two sides, however you extend, they will never meet. Even these two sides, they never meet. So opposite sides are parallel. These are the 5 important properties of rhombus. Okay, now we'll see what is the area of the rhombus. Area of the rhombus is, this is the rhombus we have. We can draw rhombus like this also, like a diamond, and it can be drawn like this also. It is just like a parallelogram, but parallelogram we will be drawing as a as a rectangle. It is only the opposite sides are equal, but here we draw it as of the 4 sides are equal to show, make all the 4 sides equal. Opposite sides are parallel and 4 sides are equal. This is a rhombus. So rhombus is also a parallelogram. It has all the properties of a parallelogram. Rhombus has all the properties of parallelogram. So we can use the formula of parallelogram itself to find the area of a rhombus. What is the area of a parallelogram? We have finished even sums in that. Yes, area of a parallelogram is base into height. This is the base, and for this base, you draw a perpendicular line from the opposite vertex. This is called the height h, and this is the base b. So area of a parallelogram is base into height. Rhombus can also be called as a parallelogram. So we can use the same formula. Area of rhombus is base into height. This is the base and this is the height. Base into height. If you are given these two measurements, base and height, then we use the formula base into height. Sometimes in a rhombus, instead of base and height, you will be given the measures of the diagonal. This is one diagonal joining opposite corners, opposite vertices. This is a diagonal and this is a diagonal. We denote the diagonals as there are 2 diagonals. So D1 is diagonal 1, D2 is diagonal 2. If you are given the 2 diagonals, measurements of the diagonals, then the area of the rhombus is half into D1 into D2. What is half? It is 1 by 2 into D1 into D2. This is the area of the rhombus. To find the area of the rhombus, we have 2 formulae. If you know the base and height, formula is base into height. If the measurements of the diagonals are given, then the area of the rhombus is 1 by 2 into D1 into D2. So this is all about the introduction of rhombus, the properties of rhombus, and the formula to find the area of the rhombus. Now using these formula, now we'll start doing the exercise sums. Okay. Now we'll start with exercise 2.2, which is about finding the area of the rhombus. Read the first question. Find the area of the rhombus PQRS shown in the following figures. Look at the first figure. PQRS is a rhombus and we are given the 2 measurements. And what are these 2 measurements? First of all, you have to find out whether the given measurements are base and height or the diagonals. What do you know? What do you guess, children? Here you are given this is 8 centimeter. This red line is 8 centimeter. What is that? Is it a base or a diagonal? Yes, it is joining the opposite vertices. PR is a diagonal, that is 8 centimeter. QS is another diagonal, which is 16 centimeters. So we are given the measurements of the 2 diagonals D1 and D2. So what is the formula when you know the diagonals? When the diagonals are given, the area of a rhombus is 1 by 2 into D1 into D2. So we'll use this formula to find the area. So this is the diagram given in the book. You are given SQ 16 centimeter, PR 8 centimeter. And how do we denote it? Diagonal 1. D1 means diagonal 1. Okay, so diagonal 1 is 16 centimeter, diagonal 2 is 8 centimeter. You can interchange, it can be interchanged also. You can take diagonal 1 as 8 and diagonal 2 as 16. However you change, we are going to multiply only. We have studied about the properties of multiplication already. Even if you change the order, the answer will not change. So any one can be taken as D1 and any other second one can be taken as D2, 16 and 18. Now, therefore, area of the rhombus is half into 1 by 2 into D1 into D2. 1 by 2 into what is diagonal 1 is 16, in diagonal 2 is 8. Now, how to simplify this? We know it's a fraction. If you want to make it clear the fraction, put by 1 so that you are very clear about the numerator and denominator. Now, which are the two numbers which can be cancelled? 16 and 2 or 8 and 2. All are even numbers. Any two numbers can be cancelled. We'll cancel 16 with 2 by 2 tables. Yes, 2 ones are 2, 2 eights are 16. Now, the denominators become 1, 1, 1. That's all. There is nothing to cancel. Multiply both the numerators. 8 eights are 64, and this is the area. What is the unit of area? It is square units. So we write square, and what is the length is given? It is given in centimeter. So 64 square centimeter is the area of this rhombus. Got it? Now look at the second one. This is the diagram of a rhombus PQRS. And what are the given measurements? PQ 15 centimeter. What is this PQ? It is the side of the rhombus. That is nothing but the base. The one side only we take it as base. And what is this 11 centimeter? This dotted line is the perpendicular line drawn from S to the side PQ. That we take it as base. So this 11 centimeter is the height and 15 centimeter is the base. In the previous one, we were given diagonal 1 and diagonal 2. But now, what measurements are given? Base and height. So what formula will you use? Area of the rhombus is base into height. So what is this 15? Is B base. Base is 15 centimeter and so area of the rhombus is base is 15 centimeter, height is 11 centimeter, height is 11, base is 15. Area of the rhombus is base into height. B for base, H for height. Base 15 centimeter into height 11. Now you have to multiply 15 into 11. That's all. You get the answer. 1 into 15 is 15. Below first number 0. Then this 1 into 15 is 15. So 5, 6 and 1. 165 what? Square centimeter. This is, you can do it in rough column. 165 square centimeter is the area of the second rhombus. So when you are given base and height, formula is base into height. When you are given the diagonals, formula is 1 by 2 into D1 into D2. Okay, children? It's very easy, no? How do you all find it? Yes, too easy. Just you should be thorough with the formulae. Now question number 2, find the area of a rhombus whose base is 14 centimeter and height is 9 centimeter. So here the previous one, the diagram was given and the measurements are marked. Here it is given as a statement. Let us draw the diagram first. Find the area of a rhombus. What is the figure we have to find? Rhombus. So draw a rhombus and you are given base is 14 centimeter and height is 9 centimeter. How do you draw the height? If you take this as the base, then the height has to be drawn from the opposite vertex and 9 centimeter is the base. So we know base and height. So which formula will you use? Yes. So area of the rhombus is base into height because we know the measurements base and height. So use the formula base into height. Base is 14 centimeter, height is 9 centimeter. So it is 14 into 9. Let us multiply. Since it is just very small numbers, we multiply like this horizontally. 9 4s are or 4 9s are 36. Write 6, carry 3. 9 1s are 9. 9 plus 3 is 12. 126 square centimeter. Unit of area is always square centimeter. Okay. How do you find it, children? It's all easy only, no? Interesting. Easy and interesting, isn't it? Yes, with all basic concepts, mathematics is always easy. It is just to enjoy. Okay, children. Thank you for watching. We'll see the rest of the sums in the next video. Thank you all.